All right, let's talk about a problem that I'm sure is on a lot of our minds. We've got these incredible large language models, right? But how do we get them to go from being a jack of all trades to a true expert in our specific domain? An expert on your company's internal code base, or a deep specialist in a particular field of science. Well, today we're going to break down a really clever paper that gives us a new recipe for doing exactly that. So let's frame this with a little analogy. Imagine your LLM has a final exam tomorrow. The subject? Your entire company's private knowledge base. Its one job is to answer questions using only that data. So how do you help it study? Do you try to force it to memorize every single page? Or do you just hand it the books on exam day and, hope for the best? This is the real challenge we're facing. And this is where the brilliant analogy from the researchers comes in. Think of it as an open book exam. In an open book exam, you don't need to have every single fact memorized, right? But what you absolutely have to know is how to use the textbook. You need to know how to find the right information, understand it, and use it to build a solid answer. It's a completely different skill set than just rote memorization. So before we get to the new, smarter way of studying, let's look at the two methods that most of us are probably using right now and explore why they don't quite hit the mark for this kind of test.
On one hand, you've got your standard supervised fine-tuning. Let's call this the closed book method. Here, you're basically forcing the model to memorize the textbook by feeding it question-answer pairs. You bake that knowledge right into its parameters. The problem is, come exam time, it has no idea how to actually use the external documents you give it. Then, on the other hand, you've got standard RAG. This is like the student who shows up for an open book exam without ever studying. Sure, they have the textbook with them, but they've never been taught how to actually use it. They're just flipping through pages, completely unprepared.
So if those two common methods are flawed, what's the right way to prepare? Well, this is where RAFT comes into the picture. It stands for Retrieval Augmented Fine-Tuning. And honestly, you can just think of it as the smart student who actually knows how to study for an open book exam. Now, to really get RAFT, we have to talk about a problem that anyone who's ever built a RAG system knows all too well: distractor documents. Let's be real. Our retrieval systems are never perfect. You ask a question, and yeah, you might get that one perfect golden document with the answer. But you're also going to get a bunch of other documents that seem related but are actually useless. These are the distractors, and they're just noise that can totally confuse the model. And this is the absolute core of the RAFT training method. It's so clever. During training, for every single question, you don't just give the model the right answer, that golden document. You intentionally throw in a few of those distractor documents right alongside it. The context becomes messy, just like in the real world. This forces the model to learn how to find the signal in the noise. It has to figure out which document is the golden one and which ones to ignore. It's basically building immunity to noisy retrieval right into the model itself. But wait, it gets even better. RAFT isn't just about finding the right answer. It's about teaching the model to show its work, to actually reason its way to the solution. And check out how it does this. The model is specifically trained to answer in a chain of thought format. So look at this example. It doesn't just spit out Delhi. No, it builds a case. It says, okay, based on this sentence I found in the text and this other sentence, therefore the answer is Delhi. It's forced to cite its sources, to quote the exact text it's using. And for us as engineers, this is a huge deal for building systems we can actually trust. So the crucial takeaway is this. The goal of RAFT is to teach the model a skill, the skill of reading, reasoning, and pulling out answers from a given context, even a noisy one. This isn't about memorization, it's about application. Okay, the theory sounds fantastic, but as engineers, we're all thinking the same thing: show me the numbers. Did this new study method actually lead to better grades on the exam? Let's take a look at the benchmarks. The researchers put RAFT through its paces on some really tough data sets. We're talking PubMed QA, which is full of specialized biomedical knowledge, and HotPot QA, which is notorious for requiring complex reasoning across multiple documents. So, how did our smart student do? Well, the grades are in and they speak for themselves. Compared to a strong baseline of domain-specific fine-tuning plus RAG, RAFT gets a solid boost on PubMed QA. But look at HotPot QA. This is wild. The baseline method basically fails, scoring just over 4%. RAFT, on the other hand, soars to over 35% accuracy. That's more than an 8x improvement. And it tells us that for these really complex tasks, teaching a model to handle distractors isn't just a nice-to-have, it's absolutely critical. So yeah, hitting 73.3% on PubMed QA really shows that RAFT has an edge in those highly technical, specialized domains where every detail matters. But honestly, this 35.28% on Hotpot QA is the real showstopper. It's a massive leap that proves just how vital this kind of training is when the questions get hard and the data gets noisy.
Okay, so the benchmarks are impressive, but let's bring it back home. What does this actually mean for you, the engineer trying to build the next great AI app? Why should you care about this new training recipe?
So here's the bottom line. First, you're going to get more accurate answers on your own specific data. Period. Second, your RAG system becomes way more robust. It learns to deal with the fact that retrievers aren't perfect. Third, thanks to that chain of thought training, you get more trustworthy answers that actually cite their sources. And finally, and this is a huge win for us in the real world, RAFT is retriever agnostic. It's a training recipe, not a whole new system. You can apply it on top of your existing RAG pipeline to make your generator model way smarter without having to re-architect everything. So let's end with this thought. The big shift here is moving away from just trying to cram knowledge into a model and toward teaching it the skill of using that knowledge effectively. It's the real difference between just memorizing something and truly understanding it. And that, right there, opens up a whole new world of possibilities. So the question I'll leave you with is this. Now that we can teach an AI how to ace an open book exam, what problems are you going to solve next?